Okay, so I think we can start. Hello, my name is Jakub Kubrynski. I'm going to talk about engineering architecture. So who is the architect? Can you raise your hands on a daily basis? Yeah, exactly. It depends on the definition. But did you realize, or do you realize, or do you think that often when we talk about the architects and we hear the word architect, we are treating it as a synonym of someone who is totally unrelated to reality. So it's someone who is focused on creating Word documents, glyphy diagrams, and he's not doing, or he or she is not doing a real work. But is it true? Is it how it looks like? Is it how it should look like? I think no. And during this presentation, I will try to show you how I changed my approach to architecture from human to something more engineering, from guesses to numbers, to metrics, and to some real stuff. So few words about me. I work as a professional software developer for over 14 years. Right now, on a daily basis, I work as a co-founder of the DevSkiller company. DevSkiller is a platform that verifies the coding skills of software developers, of DevOps, when we check if someone is able to solve some real-world cases, like instead of inverting the binary tree, which is, of course, something we do on a daily basis. Okay, we ask someone to do some real stuff, like expose some REST API, save some data into database, retrieve it, etc. So something that is word related. I also work as a trainer at Bottega company. I'm a program committee member of DevOps Poland, and I'm still an active open source contributor. So one disclaimer, yes, I'm doing a presentation from the iPad, but I still have a computer with me and I can code, seriously. So that's what we'll explain now. So when I'm doing the trainings related to the architecture, I often start from asking, what do you mean by the good architecture? Because everyone wants to have great architecture in the project. But what does it mean that the architecture is good? So, of course, the answer depends on the context. Depending if you're working in a bank, in a startup, in some financial company, there will be totally different answers, okay? But usually people say that, okay, so the good architecture needs to be scalable. It needs to be maintainable, tailored, secured, flexible, okay? Resilient, testable, and that's great. But what does it mean that the architecture is, for example, testable? It's easy to test. Great. But what does it mean that the architecture is easy to test? How can you describe and how can you measure easy? Okay, it's hard. It's hard to do that. So, okay, I want my architecture to be secure. Is your architecture secure? Of course. So what does it mean that this architecture is secure? How can you quantify it? I know it's secure. We are using latest version of all frameworks. Great, but still, how it's related to security or something like this, okay? And there is also one thing that is almost always missing in this list. It means that this architecture can be great, but needs to be implementable. I can design great architecture with transactions between file system, FTP server, and database. And it's great, it's resilient, okay? It's secure, but it's not implementable. I cannot write it. Or maybe I can, but the effort is giant, okay? So in fact, a lot of architects are designing architecture, but they have no idea if anyone can code this architecture, okay? And so that's the most important feature of the architecture. If I design something, it's something that should be able to be code. It's something that developers should be able to code, write down, run, deploy into production, etc. Okay? So the problem with architects is that often they are trying to see everything with the big picture, okay? I've attended a great talk by Ted Newart when he said, okay, imagine the situation you are going to holiday. You are entering the plane, and during the taxi, there is a security procedure, right? So you hear that, okay, so if there will be masks that will fall down, you need to put the mask on. If you are traveling with a kid, you need to put the mask on you and then on your kid, right? If you are traveling with 2 kids, then you need to apply mask on yourself and then think which one do you love more, okay? But why do we need to put this mask, okay? Because of the decompression, because plane is going really high and there is a lack of the oxygen. Do you know what are the problems triggered by lack of the oxygen? There is a problem with hallucinations, excessive self-confidence, like problems with reasoning, etc. Okay, that's the problem with the lack of the oxygen. And how it's related to the architecture. So that said then that all the architects are operating on the similar altitude that the planes, and they have no masks. Okay, so hallucinations, problems with reasoning, excessive self-confidence, it's their daily basis. Okay, that's the problem. So we are creating the architects that lives in the ivory towers and are totally unrelated to something that happens in the real, on Earth, right? So what is the architecture? What the architecture is? So it's some kind of structure of the system, of the components, relations between those components, etc. Okay? But the architecture is a science, but it's not a human, it's engineering, okay? If I can measure something on a source code level, I should be able to do exactly the same on the level of the architecture, right? Do you know how many lines of code are in your systems? Who knows? Raise your hands. Okay, like 5% of the audience, okay? So we even don't know what's the size of the applications that we are running. Another question, do you know how many of those lines, the percentage, is used on the production? Okay, 1%, 2, great, okay? So I ran such an experiment a few years ago in a big monolith system. And answer after 1 month of running Kubernetes on production was 18%. Okay, there were like 600,000 lines of code, and less than 20% were actually used during month of running on production. That was great. It was like, so we are able to remove 80% of the application, and business won't realize that something has changed. Okay, of course they said, no, maybe this is used every 2 months or every December or something like that. Yeah, sure. So we had similar problem with in DevScaler with our application. So okay, we know how many lines of code are used in the production, but we have problems with quantifying all those requirements. So of course we want our application to be scalable, to be secure, to be testable. But what does it mean? So we've found out that there is a guy, Tom Gilb, who in fact knows how to do it. So we invited him to the company, and it was like 2 days of brainwashing and terrorizing us with saying quantify and round down the scale. So we want our application, our architecture to be secure. Great, so quantify and round down the scale, okay? We want faster time to market. Great, so quantify and then apply the scale. If you are not able to add a scale, it means you don't know what you want to achieve. Okay, so that's the idea. If you can do or can apply the scale, then the question is, what's the credibility of this estimation? Are you sure that this project will change this factor or this scale by 2, by 4, by 20%? I don't know. If it's just a gut feeling and a guess, then the credibility is 0. If it's something that we've done previously and it worked, then it's 1. Okay, so that's something that we need to do. So that's the idea, that we need to quantify all our requirements and how it looks in the practice. So scale and measuring. I used to do a lot of performance tuning some time ago, and I remember still that the most important thing in performance tuning is to measure the stuff. Okay? Before doing any changes, you need to measure the performance of the application, then apply it one change at a time, and then measure it one more time. And I remember the situation when I was tuning some Hibernate stuff, and a company said that, yeah, so we have problems that our data layer is slow. We have added the second level cache. It improved situation a lot, but we still need more. Okay, so my first question is, what's the hit ratio to the second level cache? We don't know. We are not measuring it. Okay, so let's try and check. So we have enabled the statistics. No region. There is no region of the second level cache, which means there were no second level cache in this platform application. What was the reason? The reason was that they were applying some properties like the enable second level cache, and the Java util properties API works in that way. If you pass the value that is different than a string, it will always return null. So the value needs to be string. And they've passed true as a Boolean. And when Hibernate was accessing that, then the value was null. Okay? So we've changed the true from the Boolean to the string, and then the application started using second level cache. Okay? And the boost was like 5-6 times faster than before. Hit ratio around 95%, 98%. For some regions, 99.9995. Okay? Why they didn't do it properly? Because they didn't measure the situation. Okay? If I'm measuring the response time before and after applying the second level cache, I know what's the difference. If I'm just guessing, then I'm telling the business, hey, we've introduced second level cache. And the business said, yeah, I see. It works faster. How faster? Ooh, a lot. Yeah? Because it's suggestion. That's how it works. So the problem is that the same applies to the architecture. What's my target? Is something that I want to achieve, is it really a target or just a means to an end? I don't know. I need to quantify that, okay? So, for example, in my case, I can say, okay, so let's talk about a testable architecture. In my case, testable means that I want to verify communication between all components in the platform in less than 5 minutes with effectiveness of 1 undiscovered bug per month. Okay? That's my definition of testability of the architecture with the scale. Now it's something that I can measure, right? I can see what's the effectiveness, how long does it take to run all the tests, and I know that, okay, so now I will try to parallelize the test, run them in Docker containers, scale through, I don't know, 10 AWS machines to be faster, and I see how it changes my architecture. Is this architecture going to be more testable or less testable? It depends on the scale. And at this moment, we need to talk a little bit about the software craftsmanship. Okay? Software craftsmanship is often misunderstood by developers. So we treat ourselves as some kind of guards or guardians. We protect the quality, okay? We protect the values, the peace on the word, etc. Okay? However, we cannot explain, and often we don't know, why do we want to write this refactoring? Okay, you are going to refactor this part. Okay, great. Why? What do you want to achieve? I don't know. Okay. And if we cannot describe something with the numbers, with values, it's probably just bullshit. Okay? I think that it should be done, but I'm not sure. I even don't know. I think, I have gut feeling that it will improve my architecture. How? Which factors? I don't know. Stupid business. They don't allow us to do refactoring. Okay? It's all the time. The continuous war called no time for refactoring, no time for writing tests. Why you're not writing unit tests? Business is not allowing us to do that. Seriously? It's not the reason, okay? I know, for example, that introducing any newer technology allows me to develop features and business value faster, with less effort, etc. Okay? Change from Spring to Spring Boot allowed me to remove like 80% of the configuration code from my applications, right? 80% less code is 80% less errors. It's 80% less effort to do something, right? So that's the idea. But I need to know that, for example, the delivery speed or time to market is something that's important for me. If I'm, for example, writing tests to the platform, okay, I can fix the bug earlier, okay? Because I know that after fixing the bug, the platform is still working. I can release it to production without praying for not having bugs. I know that there are no bugs because my application is covered with tests, okay? If there is a CVE, like yesterday, they were like 6 CVEs introduced or announced by this people, right, to the Spring. So it's crucial to be able to release fixed versions, updated versions in hours, not in months, okay? So if I have good tests, if I have fast pipelines, I have a continuous deployment or continuous delivery, I can react really fast, right? Okay, CV, no problem. After 15 minutes, all my software on production is fixed, okay? Because time to fix and time to deploy is one of the metrics for my application, right? But I need to describe all those metrics. And if we are talking about the craftsmanship, it means that, okay, try to write the code that is good. Don't try to, I don't know, add shit because you think it's faster, okay? Usually it's not faster. Not writing unit tests is not a technical debt, okay? Not writing unit tests is doing shitty work, okay? I can sometimes add like technical debt that we'll cover later, but writing shitty code, not writing unit tests, it's not adding technical debt. It's not that writing code without tests, it's faster. I think it's slower than writing code with tests. Okay, so that's what a software craftsmanship talks about. And the next thing is that we often hear that a failure is not an option. You are not able to fail. You shouldn't fail. You should focus and do everything to not introduce the bug on production, right? Okay, but is it true that the failure is not an option? I would say no. I think that failure is an option. For example, if you have a bug, okay, and usually we have much more work to do and much more issues in the backlog in Jira than we are able to handle. So it's important to prioritize them. So there is the idea, zero bug policy, no bugs on our platform. Okay, but there can be a bug that costs the business like $1 per month. It's still a bug, but the cost of this bug is so tiny. Return on investment on fixing this bug, if we, for example, need 20 man days to fix this bug, is giant. At the same time, we could spend those 20 days to do a lot of important stuff on our platform, right? So can we leave such bug in our code or not? I think yes, and that's the technical debt. Okay? That's the real technical debt. And there are two kinds of organizations in the world. One is called the fail-safe organization. Fail-safe organization is the organization that tries to do everything to not allow any issues, any errors, any problems on production, right? So we're doing everything. We are writing thousands of acceptance tests to be sure that no bug will enter the production. We know that it's impossible. There will be always one tiny bug that will enter the production. And what then? Then we need to fix it. Okay? So let's say that our whole suite of tests takes 2 weeks. And I've introduced one bug. When can I fix it? After 2 weeks of another suite of the test. I can skip it, but then maybe I will introduce another bug to the platform. Okay? So in fact, building organization that is fail-safe, so prevents the fails, it's not effective. The other idea is the safe to fail. So I'm building the organization that is safe to fail. So I allow the fails, but the consequences of the fails are limited. There is a company called the SpaceX, Elon Musk. Everyone is talking about that. They are launching rockets into the space. And the problem with space is that there is a lot of particles flying with giant energies and hitting everything that is in the space, right? So if I have a CPU and I'm doing a simple 2 + 2 calculation, we know that it should be 4, right? But 2 and 2 in the computer is represented by zeros and ones in the memory, okay? And the memory has a normal size. Of course, I can't see 0 and 1s in my computer, but they're existing and they have dimension, right? So it's possible that this particle will hit the 0 and it will result in something that is called a bit flip. It was 0 and now it's 1 because it was hit by the particle with giant energy, right? So we can do 2 things. One, try to build some giant shield that will protect our memory, our CPUs, from being hit by the particles. It will cost a lot, it will be giant, probably it will be so big that we won't be able to launch the rocket into the space. That's the fail-safe approach. The safe-to-fail approach means, okay, we cannot eliminate the bit flips at all. It's not possible. But if we'll calculate 2 + 2 6 times on 6 different CPUs, then we'll probably 4 times get 4. Once we'll receive 0, and once we'll receive 6. So probably those 4 similar results are the valid result, is the valid sum, right? So that's the idea of safe to fail. We know that we can fail, but we are limiting the consequences. Okay, there is a bit flip, great. In one of the 6 CPUs, I used to do this simple calculation. I have still 5 that are providing me with the right value, okay? So that's the idea of the safe to fail. How we can add it into our application. For example, we are releasing the plagiarism detection. And it breaks like 5 times on production, just after releasing. Because once we have tried to parse some binary data, which the source code tokenization isn't handling very well, etc., right? So it was crashing the application. But we used the feature switch that we are just able to turn off the plagiarism detection feature, fix it, and next day put it once time. So I have really, really fast rollback. It took me like 3 seconds to roll back the functionality without changing the application in production, okay? So that's safe to fail. Being a safe to fail organization means introducing the technical debt. Okay, so as I said before, the technical debt is not an explanation for cluttering or messing up the application, the architecture, okay? It's not, we don't mean, okay, so I'm writing messy code because I'm introducing the technical debt. No, it's not the same approach, okay? But on the other hand, the technical debt isn't something that always needs to be 0, okay? We can use technical debt, we can introduce it into our application, but we need to remember that it's here, and every time if you are using that, for example, to buy a house or buy a car, it must make sense to take that instead of paying by money, okay? So we always need to think about that. Okay, so let's talk about the metrics. So for example, these are the sample metrics that we use in our architecture. First is that the database schema migration issues. That is my metric, okay? And in this fact, I want it to be equal to 0. I don't want to have any database schema migration issues on my production. Second feature or metric of my architecture, I want the cross-services communication issues to be also 0. If I'm releasing my microservice into production, I don't want to introduce the situation where it cannot talk to some collaborator because there is some issue in the communication, right? So how can we deal with that, okay? So for example, to limit the database schema migration issues, we are using Flyway to manage the migrations, and we are using our own developed tool, JPA to DDL, that is generating the migrations based on the source code automatically without human interaction. We don't want to have the cross-services communication issues. So we are using the consumer-driven contract, Spring Cloud contract application framework to protect and verify the contracts between applications, between collaborators during compilation. So if I have my jar with my application, I know that this jar that has just compiled is able to talk to all collaborators released to production, okay? Time to fix. If there is an issue, there is an error on my production, I want to fix it in less than 1 hour, okay? I'm not trying to prevent all the issues on the platform, but if the issue is introduced, I'm limiting the consequences of the issue, okay? If you are not able to add a user to the platform, it's a problem, okay? But if you know that, okay, so you will be able to add this user after 20 minutes, it's a small problem. If I will tell you, okay, sorry, there is an issue, we'll fix it. In 6 months, there will be a release that will fix this feature. Okay, no, it's stupid. So I'm limiting the consequences, so I'm limiting the time window when this bug is active on production. Next time, backup time, okay? Let's say that I want to run the backups on any of the free machines every 20 minutes, okay? So it means that my backup time is limited to 20 minutes. If it will take 25 minutes, then it means that on the one machine, it will be still executing when I will start it on the second machine. If it's less than 20 minutes, I can say that on this machine, I will run it on 0, 0, here 20 minutes, here 40 minutes. And they won't overlap, right? So that's my metric. But I know that my data is growing. I will have more and more and more data. So if my backup time currently is 10 minutes, I know that it will take like 20 minutes, 12 minutes after a few months, okay? Because my data is growing. But on the other hand, I know that I need to fix or improve the backup efficiency to be able to handle more and more data. So I have, for example, the backup efficiency set to 5 minutes per some unit, like 1 per 1 gigabyte or something like that. But I know that after some time, I will need to change this metric to 4 minutes per unit to be able to handle this 20-minute limit of this one, okay? So that's also something that we are handling here. And how it looks like when we talk, for example, about the infrastructure as code. We are using infrastructure as code as a dev skiller, and we have automated all infrastructure, everything, seriously. Why? Because it allows us to reduce and keep the recovery time on some known level, okay? Do you know how many hours or days do you need to recreate your production environment from zero, from scratch? Who knows? Okay, 1, 2, 3, 4 person. Okay, I know because I have scripts to do that, and I know how long does it take. Okay, I know that I am able to recreate the whole production in less than 4 hours. Okay, because I can do that. I have just scripts to run. Okay, so that's the idea for the infrastructure as code. So yes, I'm introducing infrastructure as code, but not because people are talking about it on conferences and because it's sexy. I'm introducing that to follow particular rules and metrics of my architecture, okay? I want my backup to be easy. If you have infrastructure as code, it means that you don't need to back up virtual machines. You don't need to back up the configuration because you are the master of the configuration. So everything that you need to back up is just a data. It improves the efficiency of the backups. Okay, we have problems with metrics with backup metrics, and introducing infrastructure as code allows us to reduce those metrics a lot. Okay, because we now just need to back up the databases, not the virtual machines, not the configuration, nothing. Okay, the portability. Okay, if I want to switch the cloud infrastructure from Azure to AWS, I just need to change the scripts. Okay, because everything is described in scripts. It's easy to understand because I can see my architecture because it's described in the code. If I want to see what's the relation between components, how many machines I have, what components are existing, I just need to open the Git repository and I see everything because it's described in the code. It's described in the Groovy DSL. So it's simple, it's easy to understand, okay? The simple also means that we want our whole infrastructure to be simple. So for example, if I'm using the application that is called users, okay, I know that it will produce the jar file that will be called users.jar. It will run in home users directory on user called users. It will log as a user. It will register into Eureka Service Discover a user application. It's in the repository users, and the artifact ID is also users. Okay, how can I be sure that all people in a company are following these principles? It's easy. For example, I'm using the Jenkins job DSL. Okay, that creates jobs on Jenkins for all applications in my company. Okay, great. So if your application is producing different artifact than the name of the application.jar, the build will fail. And you have no permission to change it because it's the convention written in the code. You need to follow this convention or go elsewhere, right? How can we deploy this application? We are deploying this application using automated scripts. We have one script for all applications in the company. And this script follows some assumptions that the name of the jar is users.jar. It writes on the user's application. It needs to start the user's service, etc., etc., etc. Okay? So there are strong conventions that are enforced. You are not able to break it because your service won't work in the whole environment. Sorry. So you need to follow those requirements. And how we use it then? So let's say that we are going to implement some issue. It's GeeCON 759, and it means that we are adding voting for presentations feature, okay? And we are doing some grooming, and there are 3 ideas of how to build this feature. First one means that we'll use the platform as a service database available in the cloud provider. Second one is that we'll use the MySQL database. And the third one, okay, let's use some NewSQL database like, I don't know, NuoDB or something like this. Okay, so normally we'll go with the NewSQL because it will look great in our CV, right? So yeah, let's build it using the NewSQL. But now I'm using the metrics, so I need to check what's the relation of all those ideas to metrics of my platform. I have a portability, right? How using the platform as a service database will impact my portability. It will add 5 more days to migrate from Azure to AWS. Why? Because in Azure, I'm using the platform database, which is a SQL server, right? And on AWS, it's something related to the MySQL. Okay, so I will need some time to migrate the data from one database to second one, to change some schema, I don't know, change types of the fields, etc. Okay? I can still do that if it makes sense, but I need to remember about this impact. Okay? Time to fix. Okay. For MySQL, we already know how to handle all issues, all errors, everything is set, so it won't change the impact, the time to fix metric. But for past database, there can be some issues that are unrelated to my software because they are introduced by the cloud developers, not cloud providers. So then if there is an issue, I need to raise an issue in the platform and then wait after someone will take, okay, yeah, there is an issue, sorry, you'll fix it in 30 minutes. So I assume that it changed my metric for 30 minutes. For the new SQL, it's a new technology. I need some time to learn how to fix the issues. So if there will be issue, I need to have 15 more minutes to be able to solve it, okay? Okay, I have also the quality metric about the issues per month. And I'm saying, okay, so I'm adding some feature. This feature can break down. So let's say that for the past database and for MySQL, it will add 1 issue per month. For the new SQL, as I'm introducing the new technology, I assume that there can be a 3 issues, right? And then I also estimate the effort, 20 days, 25, and 40 days, okay? And then I can see what are the current metrics for my application. Let's say that I have no time to do it right now, so I want to go with the past database version because I have just 20 days. Business said that it needs to be done in the end of May, okay? Great. What's my current metric of portability? Okay, so we assume that the maximum portability time is 20 days, and now it's 19 days. I'm not able to go with the past database because it will break down my portability metric. Or I can introduce a technical debt. What's the technical debt here? Okay, technical debt, it's not a mandate to fix all the issues in the code that is shown by the Sonar Cube. My technical debt will be 4 mandates on the portability, okay? To fix it, to go below the 20 days, I need to do some change to my architecture, to my platform, to my infrastructure, something like that, to gain those 4 days, okay? And to still rely on those 20 days portability metric. That's how we introduce technical debt, okay? Yes, I know that it will break down my metric, but I need to do it in this month. But I need that the first thing that I need to do after releasing this GeeCON 759 feature is to do some refactoring or some change to improve this portability, right? And going that way allows me to build the organization that is data-driven, okay? I'm not guessing. My business is not guessing because we have the numbers that are showing us if we are going in the right direction, okay? And then see, let's say that we've done some performance tuning, okay? We spent like 80 days to do that. But what's the result of this performance tuning? Oh, it improved conversion on our side by 20%, which means that the business has gained some money based on that, right? And it's extremely easy after a few months to go to the business and say, okay, we need another 80 days to do some performance tuning. What business said then? Okay, no problem. Do you expect similar improvement like the latest time? Yeah, I think it will be similar. Great. So feel free to do that. Okay? You cannot explain to the business that we need to do refactoring because we need to introduce some normal level, or I don't know, right? Business doesn't understand that at all. The only thing they understand is money. Okay? If you can show the value in money, then you'll feel free to write tests, to do refactoring or something like this. Okay? I remember the situation when we spent a lot of time on improving the Jenkins installation, introducing Jenkins DSL, etc. to speed up the development of the new components, because everything would we were going to automate everything, which means that the team that was setting up the new microservice will spend 15 minutes on setting up the whole environment instead of 10 days. Okay, how many applications do we introduce every month? 3. Okay, so it's 30 days of the savings every month. Okay, how much time do you need to fix these Jenkins? 100 man days. Okay, so we'll gain money on that after 3 months. It's great return on investment. You are feel free to spend like 100 days on playing with Jenkins, because there is a value, okay, that you can show to the business. Okay, we've changed the DNS configuration to do something, blah 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 blah. Business doesn't understand what happens. Oh, it improves the delivery of the mails by 10%. Great, good job. Okay, they see the business value, and we need to show it that way. Great. So, if we are going to introduce this, let's say, data-driven organization, it's great. But as long as you are not continuously monitoring all those metrics, it makes no sense. And the problem is that a lot of those metrics are extremely hard to measure. Let's say that business comes to us and say, okay, so we want to improve the user experience on our platform. Great. How can we measure the user experience? What's the scale for the user experience? That's the problem. That's why we've invited Tom Gilb to our company, because we have no idea, okay? And then we realized that there is some onboarding in our application, and we can measure how much time does it take to the user to complete the onboarding, and if the user is completing the onboarding in one session or in more than one session. If user is logging out from the platform because the onboarding is so fucked that he doesn't know what to do, it means that the user experience is poor, okay? So we are measuring time to complete the onboarding of the platform, okay? And the number of sessions that are used by the user to do that. That's the user experience metric. That's something that I can show on the Grafana dashboard all the time and continuously monitor. Then we add some changes, maybe technical changes like the performance tuning, maybe some business changes, and after introducing some change, we already instantaneously see what's the impact of this change to the metric, right? And often during designing of the metric, we already can think, okay, there is a great metric. Do we know how to measure it? Because I have great metrics, but as long as I can't measure them, they have totally no value. I can have some great measure of user happiness. Great, how to measure user happiness? How can you show it on the Grafana dashboard? I have no idea. So this metric sucks, can be thrown away. It makes totally no sense, okay? And then you realize that some of the metrics are really, really important, okay? Some of the metrics are really crucial to what you do. And then you say, okay, so maybe I can build some alerts based on those metrics, right? If I have a metric of time needed to compile the project on the platform, okay? And I know that, okay, so after 15 seconds, people will get frustrated that the build takes too much time, okay? So I can create the automated alert that will, I don't know, send me a message during the night or will call me to my mobile during the night, hey, there is an issue, the builds are taking 17 seconds, okay? So I use those metrics to create this whole alerting system. I have those metrics, I know what are the values, and I can build the alerting system based on that, okay? Also, I can write runbooks, how to deal with the problem. Because if you are being away at 2 a.m. after the party and you need to fix some issue, you need to have a detailed description of what you need to do, what are the checks, how you can deal with this issue, okay? So that's also something that's related to this one. And is it hard to implement that? No, it's extremely easy. Unfortunately, you need to use a lot of software to do it properly. So for example, we are using the micrometer with Spring Boot to produce the metrics from the application. Okay, we are using New Relic agents to continuously measure the performance of the application. Okay, then we are using the Prometheus database to manage all the short-living metrics, like the continuous monitoring metrics in the platform. Okay, on the Prometheus there is an alert manager that you can write in code. Of course, everything is as code, right? The alerts, like if this metric has value greater than 5 for the 2 minutes, then it's the critical issue. And we are triggering, using the REST API, an incident on the OpsGenie platform. OpsGenie and PagerDuty, it's the same way of incident management platforms, right? When we are triggering an alert that is calling you on mobile if you are on support duty, to fix the issue, and it's all automated. So we don't need to use any NOC services, people being awake all the night and looking at the metrics, because it's automated. We know how to automate it because we know what are the metrics of my platform. I know what does it mean that my platform is working correctly, because I know that it means that all those metrics from those dashboards are green. If one of the key metrics is not green, it means I have an incident and I need to care about that, okay? We are also using influxdb, which is a long time storage for metrics, okay? So in Prometheus, you can keep metrics for like 7 days, 14 days, and that's all, okay? And I want to check what is the trend of those metrics for the last I don't know, 2 years. So then I need InfluxDB to do that. Of course, we are using the famous Grafana to render all those metrics, show it to the business, to the developers, etc., etc. And we are also using Redash to run some business analysis to see what's the difference of some metrics, what are some metrics related to the business data stored in the transactional databases, etc. Okay? Okay, so what are the key takeaways for you from this talk? First, if you have your architecture and you want to change or improve this architecture, first thing that you should do is to round down your requirements. Quantify all requirements with scales. Okay, great. You want your architecture to be scalable. Great. What does it mean? What's the scale of scalability of your platform? Okay? If you already write down all those scales, collect the initial values, correct the current values that runs on your platform right now, okay? And now the question, how much time do you think is needed to do this first thing? So write down all requirements with scales. So generally, it's something that, for example, I do with clients in less than 1 day for the whole architecture, for the whole platform. So it's not the process that will take you like years to do that. You're able to sit down, spend 4 hours, and after 4 hours you will have key metrics of your application described with scales. Okay? Collecting the initial values based on what you have, what are the metrics that you currently implemented in the platform, what do you want to measure, takes from 2 hours to, I don't know, few days. But it's still something that can be done in, I don't know, less than a week. Then you are starting the real-time measurement. And now that's the problem, because we need to introduce metrics into our application. Right. In Spring Boot, it's something that takes around 15 minutes, probably, to introduce metrics into the application. Okay? And a few days to set up this whole Prometheus InfluxDB cluster, etc. But adding metric to application, in 30 minutes, I can add all critical metrics to any application that's running in my company, okay? And it's almost all. Then you need to remember about considering all those metrics when making any changes related to the architecture. And the good thing is that then you can design some changes to improve those metrics. And when you call those metrics KPIs, then business is really eager to give you money to do that, because business loves KPIs, okay? Okay, so why do you want to get like 100 days to do something? Okay, because I have such metric, like time to fix, time to deploy, and I want to go down from 5 hours to 1 hour. Okay, that's something that I can understand. That's something that I can measure, okay? How business can check if the refactoring is done? We are saying, yeah, take a look at this code, you see? No more than 80 lines of code in any method. And business said, yeah, that's great, okay? They don't care about that. But if you show them that you are able to release the software in 1 hour instead of 4, that you are able to introduce the fix to production in 15 minutes instead of 4 hours, that's something that makes value for them, and they are willing to pay you for that. And that's all. Thank you very much. If you have any questions, I will be here for a moment, so feel free. Thanks.